Recording and transcription. Oh, that's cool. Good morning. Recording in progress. Share my desktop. Okay, for people online, can you see my slides first page? Like a red curtain. Can you see them? Hello, people online, can you see my first page of slide?
Yeah.
Yes, yeah. So please give me some feedback, because I don't know if they are still there or not. Okay. All right, let's get started. Again, good morning, everyone. This is the second session of my series of RStudio workshops for SEB 113 students. If you're studying SEB 113, you're also welcome to join us. So for people who didn't come to my orientation session last Thursday, my name is Yulin from Student Success Group of QUT. I teach some data science, statistics stuff to you guys and other students. First of all, I did last week, I think. I like to acknowledge the traditional owners of the land, the Aboriginal owners of the land of QUT, and where QUT stands today. I think they are called Turrbal and Yarraga communities. So first of all, please register for my sessions every week. I have 2 hours every week, week 1 to week 13. Why? First of all, I can have an idea about how many people will show up. Secondly, I will email all the registrants before and after my session. So if you didn't register for the sessions, you won't get my email. Okay, so I will email people the day before my session about some housekeeping stuff. And also after the session, I will also email people who booked themselves in the workshop about the recording, the link to download the materials, etc., etc. Okay. So again, please log the attendance form. That will be in the email as well afterwards. And also, if you have a few more seconds, just give me some feedback, just make some rating about my teaching. I just need those numbers. All right. So last week we talked about how to install RStudio and R. You have to install both of them. Okay. RStudio is the platform for us to use R. R is a programming language specifically designed for data analysis, statistical science. Okay. And then we talk about, you remember working directory? That's the folder you have to nominate for saving your stuff for your RStudio session. Okay, and then we talk about R script. Remember the syntax in R is a case sensitive. So lowercase, uppercase, they are different things. Okay, it's case sensitive. People can hear me online? All good?
Yeah.
Okay, thanks. Thank you. And then we talk about workspace. So basically, we can't finish a project in one go. Sometimes we have to stop or pause. So you can save the progress of your project in your session into a workspace file, and then reload it next time you start or you continue on your project, right? Yeah, it just makes things more efficient. And then we talk about packages. So there are heaps of packages in R. Some are automatically installed when you download and install R. But many more of them you have to install separately. Okay. Last week we installed a package called the Tidyverse, if you still remember. Okay. Yeah, Tidyverse is very handy. It's very useful for data processing and data analysis. And more importantly, you have to use Tidyverse for your assignments in SEB 113. Okay, so no matter you want to learn or not, you have to, to be honest, Tidyverse. Okay, so a package can be installed normally once a year or once every 5 years. I don't know. So you don't have to reinstall a package very often, because once you install, it's always on your machine. But every time once you start an RStudio session and then you want to use some packages, you have to load them. Okay, how to load the package? We use the library function, right? Library and package name. Okay, yeah, just what we learned last time. And then we had the exploration of the Star Wars data set about the characters, and then we try to find out how tall and heavy and old is Yoda. You still remember Yoda? All right, okay, we can continue now. All right, now today, I just scrolled down my slides. Okay, I won't put in the show mode. Okay. So today we talk about how to import, export, and explore data in spreadsheets. You have to know this because most of the time you are working with data in spreadsheets. Okay, so first of all, you have to get data into your RStudio session, and then you can work on that. Okay, yeah, and then more importantly, your assignments in SE V113, the data all in spreadsheets format. So we have to know how to deal with this stuff. Okay, and then we'll talk about little bit about the data types. Okay, yeah, in the second half of this workshop. We probably will finish before. So I schedule it for 2 hours. I think we can finish maybe 1.5 hours, something like that. Okay. All right. First of all, let me start my RStudio session. So I'm using Windows 10, is it? I think. So I go to Start button and RStudio. Okay. I have my RStudio and R installed long time ago. Okay. My version is a bit dated. You guys probably using a more recent version of the RStudio than me. Okay, that's the stuff I did last time. Oh, some update. Okay, remind me later. Okay, once you start the RStudio, it's probably look like this. Okay, we have the console panel here. This is the console, and this is the global environment. Right, top right, and then right is kind of management and panel here. All right, so what do we do? First of all, very often your data in spreadsheets may be saved as a Excel file or CSV file or TXT. Okay, so how to load a spreadsheet of data in Excel, TXT, or CSV file into RStudio? That's very simple, very easy, very simple. Okay. So first of all, as a good habit, we need to check our working directory, or we need to nominate our working directory. Okay, so I'm going to create a project folder on my desktop. Okay, suppose this is my first assignment. I call this one assignment 1. This is my assignment 1 project folder, and then I'm going to use that project folder as my working directory. So what should I do? If you last time we learned, we go to session, set working directory, and then choose working directory. Okay, and then just use Explorer to find out the folder. I think it's in my desktop, and then the folder is here, assignment 1, and then click open. All right, so I'm pretty sure my current working directory is that folder on my desktop. If you on double check, you can type in your console, you can type get wd and a pair of open brackets, get wd working directory, and then enter. That's it. It tells us, okay, my current working directory is in C drive, users LSU34, that's my Qt username, and then desktop assignment 1. Okay, yeah. The good thing of setting up the working directory as that folder is that every time I load or import or export something, that folder will be the default location. Okay, so now suppose I have a data set in that folder I want to import in my RStudio for further analysis. So I'm going to create let's see, I'm going to create an Excel spreadsheet or Excel workbook. Okay, data. Okay, just you can do the same thing. Just call whatever you like. You can create an Excel file, or if you like CSV file or TXT file, doesn't matter. And then I'm going to put some fake data in there, just for demonstration purpose. Okay. You had your first lecture, right, on Tuesday? I assume you attended the lecture, or virtually attended. All right. So let's say we have 3 variables. Okay. Name, gender. Suppose this is a student data set about the students. Okay. And then let's see. I think gender. What else? Q. Okay, so I have 3 guys in there. First one is Lucas. Second one, maybe me. Next one, Zane. Okay, they're the people I know. Second one is me, and then the other 2 are the people I know, the real people I know. Maybe I'll put a girl there, Natalie. Okay, so this gender is let's see, maybe I call this sex, make it easier. Female, male. This guy is male. And Lucas is male. IQ, Lucas is 120. Julian, maybe 100. Zane, 110. Natalie, let's see, 105. Okay, I'm okay with my data set. That's complicated enough. I have 3 variables, or 3 features, or 3 attributes, or 3 columns, or 3 fields, whatever you call them, they all mean the same thing. Okay, statistical terms is a nightmare in different fields, different disciplines, or even within the same discipline, people call the same thing different names. Okay, yeah. The people use different names for the same thing. So like column, fields, feature, attribute, variable, etc. Okay, they all mean the same thing. And even worse, people use the same name for different things. In statistics, it happens. Right? Yeah. It could, even in one paper, the same terminology can mean different things in different contexts. So that's why teaching yourself statistics can be a challenge, okay, but also fun. All right. So I save it. I'm close it. The computer is not that fast. You can see. I don't know what's wrong. Maybe it's too early in the morning. All right. So now I'm going to import this Excel spreadsheet. Actually, it's Excel workbook. And in one Excel workbook, you can have multiple spreadsheets or worksheets, right? So I'm going to import that worksheets in this workbook into my RStudio session. So what do? Go to my slides. So place your spreadsheet file in your project folder or working directory, and then to import the data, we just need to go to File, Import Dataset, and from whatever format we like. Okay, so File, Import Dataset is here. Okay. Here. File, Import Dataset. Where's the import dataset? Here. Around here. File, Import Dataset. And then my data is Excel spreadsheet or worksheet within Excel workbook. So it's from Excel. File, import dataset from Excel. You can see we can also input data in other formats, like from text means the data is a CSV file or .txt file. that you use from text. And then if you have other data sets in the commonly used commercial packages, for example, SPSS, SAS, STATA, Stata, they are the three most commonly used commercial statistical analysis packages used by social sciences, psychology researchers, econometricians, quantity economists, and also finance people. Okay, yeah. You can also data set in those formats. Yeah. But I prefer R because R is open source and free. Those three are not open source, so you can't do whatever you like. You can, but it's not that common used. And then it's not free. It's very, very, very expensive. You can Google how much they are. They charge you by year or by term, maybe $1,000, $2,000 per year, something like that. I wouldn't pay for that. Yeah. But anyway, it's shouldn't be recorded. Anyway, from Excel. All right, so it's a graphic user interface. So we don't have to do any coding. Okay. If you like, the code is here. The code is generated for you automatically. Okay. But I just want to do as less coding as I can because I'm not a professional computer coder. Okay. You may be if you studying IT or something, but I'm not. So find the file. Again, just choose browse. Automatically, your working directory folder is open. So if I didn't set up the working directory, it won't be this easy. But because I set up my working directory here.
How did you get?
This one, browse.
Oh no, with the how do you get to that?
This one.
Yeah.
File. Import data sets. It's kind of, and then from Excel. Yeah, and then we browse. So my working directory folder, my assignment 1 folder is open, and then choose this. This is the file I want to import. Click what? Open. Yeah. And then it will generate some data preview. Okay. The preview is overview because my file is very small. Only 3 rows, 3 columns. 4 rows, 4 columns. 4 entries, 4 columns. The first row is a variable name. Okay. We have 4 cases, 4 cases, 4 entries, 4 observations, 4 individuals, 4 subjects. They all mean the same thing. Okay, 3 columns, 3 attributes, 3 variables, 3 features, 3 fields, 3 columns. They all mean the same thing. All right. Yeah. So it's a 4 times 3 size data set. The dimension is 4 times 3, 4 rows, 3 columns. All right. So basically, the button of import is hidden somewhere down there. So we have to screw the bar a little bit to the bottom. Import. Yeah. If you want to change the name, so basically once you click import, RStudio will create or import the data set into your RStudio session. So basically RStudio will create a data frame object in your RStudio session, in your working memory of your machine. Okay. It's a copy of the data set you want to import. It's a copy of the Excel spreadsheet you want to import. So you can rename the copy of the object you're going to create. Okay, so if you don't rename it, it will use the data file name. Okay, for me, it's called the it's called the data, the Excel file. But if I want to rename it, so I can call it demo data. Demo data. Okay, demo data. So demo data will be the data frame object I'm going to create in my RStudio session. Okay, and then I think I can import now. First row is variable names. Yeah, but by default it's ticked. Okay, and then I will open my data once it's imported. Okay, double check import. Did you get the same thing? Yeah, you can have a cheer for yourself. We succeed in the importing data set. So you can see we have a data frame object created in my current working environment. The current session, the temporary memory of your computer is called the demo data. It has 4 variables, 4 observations and 3 variables, and then it's open here, so you can see the data set. Okay, you can close it if you don't want to see it. And if you want to see it again, just go to the global environment, hover on the data frame, and then double click it. It will be open again. Okay, it's like a spreadsheet view of your data. Otherwise, if you want to use the code to drive it, you have to type view, capital view, and then the data frame name, and then enter. Okay, so whatever you did here, the code is generated here in the console. View demo, capital view, capital is a case sensitive. Remember, our code is a case sensitive. All right, so I think that's perfectly correct. Okay, everything's good. Name 6 IQ, 4 guys, 3 guys, 1 lady. All right. That's how to create how to import data from a spreadsheet. Very often, many people are using Excel today. Okay, yeah. You can also import data in CSV file. CSV means comma separated values. Okay, or TXT file. Excel is very often, because I read the article yesterday, or not just last week. Remember, you know, we have lots of genes in our human body. Yeah. Obviously, the human biologists, they use Excel file a lot. And then, you know, in Excel, if you type something like that looks like a date, like March 03, Excel will automatically convert that column into a format of dates. So obviously, we have lots of gene names, human gene names. They look like a date, like March 3. So previously, lots of error happens in the analysis of biology because they use Excel a lot, and then very often Excel will mistake those gene names as a dates. So what happened? So a couple of years ago, the international community of biologists they decided to change the gene names, 27 something human gene names, to something else, just because Excel tend to mess up their data format. Like a March 3 used to be some gene about your finger. Now it's called a March F3. So it's easier to change your gene names than changing the Excel setting. It's true. Okay, you can Google. Yeah, it's true. It's true story. Okay. All right. So yeah, and then so of course you can rename your data set once it's imported, just like here. Okay. Okay. So for example, I don't want this name anymore. I want to have a new name. I can do this. I can let me open a new file. New file RScript. Okay, let's do a new file RScript. That's the thing we learned last time. RScript. RScript is a syntax file. It's a file to save your syntax. It's just a text file, nothing fancy. Okay, so let's say I want to rename my data set. I don't want to call it demo data anymore. I want to call it demo data. I want to call it SEB113 demo data. Okay, so call this SEB113 demo data. Okay, that's the new name of my data set, and then it comes from this one, demo data. You get hints. That's the beauty of working in RStudio. You get hints when you're coding. Let's choose this one. So this syntax means I'm going to assign the object for the demo data currently sitting in my global environment. I'm going to assign this one to a new object called a SEB113 demo data. Basically, making a copy of the demo data. Just give a new name. Okay. How to run a line? You can highlight the line and then click run, or put your cursor at the end and then Control Enter, or put the cursor at the beginning and then click run. Okay, whichever way you like is fine. Okay, I just run this line of code. I just made a copy of my demo data, but with a different name. Okay, and then I can remove the original one by typing rm and then demo. At the end of the line, Control Enter, or if you're using MacBook, it's probably Command Enter. I'm not quite familiar with Macintosh system. Yes. Okay. Right. Okay, just simple tricks. How about people online? Are you guys still following me?
Yeah.
Oh, we have more people here. Good. Are you still following me? Good.
Yep.
If you have any questions, feel free to speak out. Okay, yell out. And then I'm going to repost the link to attendance form for online people. Here's the link to attendance form. Yes, I will record this for Donya. Donya, I will record. I'm recording this now. Yeah. All right. So for people online, if you come across a problem, just speak out. Okay, you just speak up. All right. Keep going. Next. All right. Again, we did this last time, but since so many people didn't come here last time, I'm going to quickly do it again. So we're going to we learn how to import the data set from a local machine, from a computer, the data set in spreadsheet. Sometimes we have a data set within the packages. Okay, so for example, we have this one, Star Wars characters in the package of tidyverse. So we can load this package and then have a copy of the original tidyverse Star Wars dataset. Okay, so I'm going to type library. That's how we load a package that we have already installed. So for me, it's called a tidyverse. For everyone, it's called tidyverse. Okay, if you haven't installed this package and then you run this line, you will get error. Okay, so if you haven't installed tidyverse, please install tidyverse. How to install tidyverse? Install dot packages, and then type the package name tidyverse within a pair of double quotes, and then it has to be case sensitive and then 100% precise. Tidyverse, T-I-D-Y, V-E-R-S-E, tidyverse. So if you haven't installed this package, please install it. I have installed them already, so I'm not going to run it. So I put this line into the comment. You put the hashtag at the beginning of the line. That line becomes comment. It's not the code anymore. Okay. So I'm going to load this package tidyverse. Run load. I see this red button here. That means the computer is running. It's doing something. Okay. And if it keeps doing, if the red button is there forever, keep doing, never stop, that means you are in a dead loop. So you have to quit the session. Okay. Hopefully it doesn't happen to you. Okay. So I think my tidyverse package is already loaded. I get some red words. They are just warning messages. They are not errors. They're just warning messages. It's just to remind me that your package is a bit older than your it's a bit older. Okay. Something. It's fine. I'm okay with that. So I'm going to let's have a look at the data set called Star Wars, lowercase Star Wars. We get a hint, right? Why we get a hint? Because I loaded the tidyverse package successfully. If I didn't load the tidyverse package successfully, I won't get this hint. Okay, I got this hint. Star Wars, lowercase. This is a data set. Okay, so we can view it. Okay, so capital V. View. We can view this data set. Star Wars. It's a data set included in the tidyverse package. Okay, Command Enter. Yeah, see, this is the one we saw last week. If you came here last week, it has a 78 for 87 rows, 87 characters, and then 14 variables, I think. And then last time we try to find out how tall and heavy and old is a Yuda. Yuda is somewhere in the middle. Here's Yuda. Here, Yuda. Yuda height is 66. Mass, I guess, is body weight. Is a 896. What do they mean? We can run this code, question mark Star Wars, to have some background information about this data frame. We go to our syntax, and question mark Star Wars, and then run this line. And then at the bottom right corner, you will see some background information about this data set, Star Wars characters. So how it was created, and then the variable names, and then the meaning. Okay, 87 rows, 14 variables. Height means height in centimeter. So Yoda is about 66 centimeters tall. Yeah. If the data set is in the package, you don't have to import from the folder. But if you want to export something, if you want to save something, I recommend you set up your working directory at the beginning, and then that files will be saved into your working directory. Yeah, we're going to do it next time. And then next step. Yeah. Now, yeah, if you don't save it, if you don't export out, once you quit the session, everything will be washed off from your processing memory of the PC. So the height is a centimeter, the mass is a weight in kg. So Yoda is about 17 kilograms heavy, and the birth year is a YBB. Is a BBY, is a before the Battle of Yavin. Okay, if you know the storyline of Star Wars, you know what it means. Okay. All right. So what we need to do is we're going to create a copy of the Star Wars data set, a data frame. So again, you can name whatever you like. I'm going to name it SW. It's a copy of the Star Wars data frame. Control Enter. So now I have two objects. They both are data frames in my current global environment or processing memory of the computer. Okay, 87 guys, 14 variables. And then there's one very commonly used function called a summary at the bottom of my page here. Summary, and then you put a data frame name in there. This is a quick way to calculate the basic summary statistics of every single variable in your data frame, your data spreadsheet. Okay, summary. Summary is a base function in R. That means once you install R, the summary function is available. Don't confuse the summary function with summarize function. Summarize function is a function in tidyverse. So summarize is only available once you load the tidyverse package. So summarize is a bit more complicated. We will learn how to use it next week in my workshop, and you probably will learn it earlier in your SEB 113 practical sessions. Okay, but we will use summarize as well. Summary is a base function in R, which is very basic. Okay, so summary, and then we type our data frame name. I just type SW, the one we just created, the copy, and then run this line. Run is the run button, and the output is here in your console. So every time you get some statistical output, it will be shown in your console. Okay, so summary calculates the summary statistics of every single variable. So name is a character variable. Height is a numerical variable. So if it's numerical variable, it will calculate the minimum, median, first quartile, third quartile, the average, the mean, the maximum, and the number of missing values. Remember in RStudio, in R, if you put a value as NA, that means missing value. So have a look at my data set here. The Star Wars data set is very messy because it has many missing values in many columns, like a hair color. So for the first one, Luke Skywalker, it's a blonde. I think the spelling is probably not right. Blonde. I mean, okay. And for the others, is a missing value. Like for these two robots, of course they don't have hair. R2D2. The hair color is NA. So NA means missing value. Okay, so don't be. Remember in R, NA means missing value, and then we kind of hate missing values because it makes things more complicated, right? Missing values, and then it's quite messy. Okay, yeah. So today we're going to learn. Next week we're going to learn how to make data more organized for ready for analysis next week. Okay, using tidyverse functions. Okay. So NA is missing value. Okay. Let's continue. Okay. I just want to introduce a quick way to edit your data in the data frame. Just quickly, you may or may not want to use it. Okay. I just come across this quickly the other day, or maybe sometime last semester. So if you use the fixed function, we can open up data frame in a spreadsheet view, like Excel spreadsheet, and then in that view we can change the variable names. We can change the values in the cells. We can also switch between character and then numerical variables. We can change variable types. We talk about variable types in the next few slides. Okay, so let's give it a try. So just let's say just type fix fix. Again, it's a basic function. Okay, and then put your data frame name within the brackets and then run it. Okay, you should get this data editor view. And then you can do something here. Okay. If you click the variable names, you can change the name. Okay. Before it's called a variable, it's called name. I can call this one a name underscore. I call them row name. Okay. And then if I close, and then reopen my data frame, the variable name is changed to row name. Okay. Yeah. It's just a quick way to change things. Run this again. You can also change the variable type. There's only two options here, either character or numeric. Okay, very basic function here. Yeah. And then more importantly, if you double click the cell, you can change the values in the cell. Okay, yeah. It's just a quick handy way to do things, you know. Next week, we will learn how to do things more formally using tidyverse functions, using syntax. Okay, but if you want to just do some small fix within a second. Okay, you can do it this way. Okay, but remember, note down everything you did. Either put in the notes or somewhere to record what you did to your data. Okay, because you use you are using the graphic user interface to edit things. Those things are not recorded. Okay, so remember, make a log of all the changes you made to your data set. Otherwise, use syntax to do the changes. We will learn how to do them next week. Okay, yeah. So suppose I have some multiple lines of nodes, and then I can highlight them, and then go to, remember last week, go to code, comment the lines. They all become nodes. Okay, remember this little trick, code. You can switch between comment and uncomment the lines you highlighted. As a quick way to add a hashtag or remove hashtag at the beginning of each line. Remember this trick? Yeah. And also remember last week we have another trick. If you want to have a heading, suppose you have 200 lines of code and you have 3 sections, you can divide your a long file of R script into sections and then have a heading of each section. How to make a heading? Just start a command line and then end a command line with 4 hashtags. And then call this one. Okay, I'll show you. And then go to code, show comment outline. Code, show comment outline. Have outline. And then, of course, that doesn't make sense here. I'm going to call this one section 1. Okay. And then you have another bunch of codes later, 200 lines later, and then you can call this one section 2. Have some comments here. And then it's the section 2, just imagine, okay? And then I'll call this one section 2. And then I'll make the headline, or not box, 4 hashtags, section 2. Just a nice trick to organize your code, okay? Later on, you will work on some big projects. You may have 1,000 of lines of codes in one file. You probably have to organize. That will make your navigation easier, okay? But if your file is 1,000 lines, you probably need to think about how to divide them into different files, not just one file. It's a little trick, okay? If you don't want this view, just go to code, show comment online, it will disappear. Okay.
For the assignment, you know, if we have to upload.
Yes, for SCP 103 assignment, you have to submit your code. Yes, yeah, you have to think about the marker psychology. Because they are expect to mark maybe 100 reports within 2 weeks, something. Make them feel comfortable. And then the looks matter, all right? The looks matter for report writing. Yeah. All right. Okay, that's a quick little function, fix function. Okay, yeah, it could be useful. And then we're going to learn how to export data. And then after this one, we have a quick break. And then in the second half of the workshop, we'll learn how to explore. We talk about the data types, variable types. We will finish definitely around 11:30. And if you need to go after this little part, export data, you're free to go because I'm recording. I will share you with the links to my recording. This will be on my YouTube channel and in my after session email. Okay, that's why I remind you to register for the sessions. Okay. Even you can only stay for half an hour or 1 hour is okay because once you're registered, you won't miss my before and after emails. All right, export data. That's easy. So suppose we have did some massage to my SW data. We change some variable names. We delete some rows. We change some columns. Okay, we will remove some columns, we change some values. Just imagine, we do that next week. Okay, next week we talk about how to. Next week we talk about how to select the columns you want, how to rename the columns properly using syntax, how to select the rows you want, how to delete the rows with missing value, and how to create some new columns based on the current columns. For example, we can create a BMI, body mass index column based on the height and the weight. Okay, and then save your processed data set using the syntax. Yeah. So suppose we did all the stuff, okay, all the data wrangling, we call them data cleansing or whatever, and then I want to save my data file as a Excel spreadsheet or TXT file or CSV file. How do I do that? Very simple. Okay, just all on this page. So because I set up my working directory, the file will be saved in my working directory. Okay, and then the syntax is here. This one. Write.table, and then we're using the write.table function. And in this function, in the brackets, we have to first of all we type the name of the data set or data frame object we want to export, and then we type file equal. So the file equal, this is where you name the TXT file or Excel file you want to save in your project folder. And then you specify what type of file you want to create. So suppose I want to create a CSV file. The separator has to be comma because CSV means comma separate values. Okay, so let's do it together. So write.table. I'm going to my R script. Okay. I will type write.table. Yeah, so that's the advantage of using RStudio. You get hints, like a professional coding environment. You get hints. This thing's called a hint. Write.table. That's the function. And then first of all, we have to choose the object, the data frame you want to export. So for me, I want to export SW. Okay, just imagine we have done some massage with SW. We remove the ones we don't want. We create some new variables. Just imagine we did that already. Okay, and then comma, and then file name. So file name. Let me have a look again. Comma file equal to. So and then type file and double quotes. File equal to. So here you specify the future data set file's name you want to create in your project folder. So I'm going to call this one clean data dot CSV. Close the close the double quotation marks. Okay, so I'm going to export my data frame SW into a CSV file called clean data, and that will be saved in my working directory. Okay, so file is the location where you specify your future exported data file's name. Okay, since I want the CSV file, I need to tell RStudio the separator will be the comma. The separator is comma. So SEP is the separator is comma. Here is here. What's wrong with my? All right. Close the bracket. I think that's all we need. Let me give it a try. Run. All right, it probably run because I didn't see anything red here. If I have error, I will see something red. So nothing red. That's good. All right, and let's have a check. Go to my project folder. Go to my working directory. Yay! That's the file I just exported. That's the SW data frame I just exported, and then I name it as a clean data. It's a CSV file. Because I have a Microsoft Excel installed, you will see the Excel icon because CSV file, if you double click, it will be opened in the Excel spreadsheet as an Excel spreadsheet. But it's not Excel file, it's a CSV file. See here? It's a CSV file. So you can't do all the fancy coloring, formatting stuff. You can, but once you save it, it won't be saved unless you save it as Excel spreadsheet. Okay, so suppose you do some coloring, you do some formatting, okay, okay, and then if I save it, and close it. Is it saved? Oh no, I don't think so. Yes, it's not saved. Yeah. So all the fancy stuff will not save because it's a CSV file. So if I right click, open as a open with a WordPad or Notepad, it's just like this. Commas separate values. The values are separated by commas. Okay, it's a big mess. Not because you did something wrong. The big mess is because the data set is a mess. This guy, the Star Wars data set itself is a mess. It's a big mess. If I save my SEB113 data set, if I go back, if I save my not SW, if I save my SEB 113 let's go clean demo data. Something wrong with here. Yeah. So if I save my SCP-113 demo data, let's see what happens. Okay. And this time I want to save it as a TXT file. Okay. TXT file. TXT file you can choose the separate as either tab or space. Okay. CSV file the separators are commas. TXT file the separators can be either tab or space. So if you choose tab is a /T. If a space, just put a space here. So okay, I'm going to call this one. I'm going to see my little file here, this one. 4 rows, 3 columns, the SCP-113 data. And the name is SCP-11_data. And then it calls TXT. And then I use a separator as I just put a space here, one space. My cursor was funny before because I accidentally pressed the insert. Yeah, don't do that. All right, let's do it. Let's run this line of code. Control Enter. So TXT file, and then if I right click, I'll just open that. It's very nice. They are separated by the values are separated by space. Space. Yeah. Space. Yeah. Question.
Getting a red arrow, unexpected string. Unexpected string constant.
String. Okay, I'll come to. Let's have a quick break. Until let's have a 5 minutes break. Okay. So now it's 57. we'll start probably at 11, and then we'll finish by 11:30. I'm pretty confident with that. Okay, yeah. Let's have a quick break. Any questions online? Just you out. No?
Yeah, I do have a question actually. When I save the file, and then I go to look at it again in my folder, it doesn't have the .txt or the .csv.
Did you write here?
Yeah.
That's probably because your setup, the setup of your file management system. Right?
Okay, cool.
Yeah, so I know in some systems, they don't show the appendix of your file name.
Yep.
Yeah, and then you probably can change it here or something like.
Yeah, I'll change it. Thank you.
Yeah. I know. It's that's the setting of the how you view the files in your folder.
Yep. Thanks.
Yeah, we will start again, resume at 11:05. Yeah, sure. And then if you need to leave, feel free to leave. I will share the recording later this afternoon. All right. Are people in the room? Just stand up, move around. And if you have any questions, just yell out. Next week, I will have Dylan who come to meeting with that group. Her name is Lee. She's completing student the final year of honors, and she has an amazing GPA. 7.776. So she's in her 6th year. She's graduating nursing, I think. Her average GPA is 6.8. And she's done it. Also many units. Gives some sense. And then feel free to talk to her, ask about learning advice, tips about how to lay out the units. With some, she will be there next time. And next session. Separating is how to separate the elements. Even on the isolation of the towers, cannot continue. We have that stuff again. Which slide? They're really looking on the top. Always this. It doesn't work again if it's studying the section number. All right, so bypass one second. And change you. Will I say that everything? If I say when I start this thing that I think there's a trouble with it. And you change the reason. Project. Yeah. Yeah, so last time we learned how to do once you set up your working directory and then you have some code in your app. So okay, people are back. It's almost yes, it's 11:07. So suppose I want to save my R script because I've set up my working directory. So once I click save, this save button of file, save. This R script file will be saved in my working directory. So if you save it for the first time, you have to give it a name. So I call this one script 1. Okay, and then I can double check. I go to my working directory, the project folder. I see this file here, script1.r. .r means it's an R script file. So it's just a syntax file. So basically, if you don't have RStudio installed on your machine, you can still open it by right-click, open as a text. It's just text, nothing fancy. The .r file is just a script text. Yeah. People still online? Oh, all right. So let's continue. Almost done. I'm still recording myself, I think. Yes. We'll finish very soon. So we just use the next about 10 minutes or so talk about the data types and the math operations. So there are different types of data or variables that are recognized in R language. Okay, so you can have a quick overview of the types of the variables. So you can use either str. Str stands for structure, and then your dataset name. You can give a try here. Str, my dataset name is SW, the copy of Star Wars. Okay, and Control Enter. It's very messy. Not too bad. Yeah, you can see we have a 14 variables, 87 rows, and the 14 variables. These are the variables names: row name, height, mass, hair color, skin color, color. And then the types are here. CHR stands for character variable. That means the values in this column, in this variable, they are just characters, text, names, whatever, labels. Okay. NUM means numerical. That's the height in centimeter, numerical. For numerical column or numerical variable, the values have to be numbers. Either whole numbers or decimal, both are okay. Okay, yeah. It's a bit messy. If I have a tidyverse loaded, you can use a better option. This is called glimpse. Glimpse is a better option than str function. Yeah. Str function is a basic function in R. Glimpse is a function in tidyverse. So if I want to use glimpse, I should have a tidyverse loaded. And luckily, I have tidyverse loaded before. Okay, so I can try the glimpse function. Glimpse, see the hint? Yeah. And then it's more organized, I think, glimpse. I highlight glimpse. Yeah, it looks neater. Right. 87 rows, 14 columns compared to the output of a str function. And then we don't have the rubbish at the bottom. So it shows the variable, each column's name and the type, and also some values in that column. Yeah. Just look at here. So if the values are just names, labels, like gender, sex, religion, suburb, names, first name, last name. Those values are normally in a column as a character variable. Character. And if the values have numerical meanings, and then some are decimal, some are whole numbers, you probably want to save them as a numerical variable. Numeric. Okay. Yeah. And the special case of numerical, so integer. Integer variable can only save whole numbers. Yeah. You can't save decimal numbers in the integer type of column or variable. So integer, numerical, that's the only difference. Yeah. And the character, the values are names. And the factor is a special one. The factor in our language means the values in this column, they are categories. And those categories, they have a kind of internal ordering. So for example, level of happiness. And they're supposed to have 5 levels. Very unhappy, unhappy, whatever, happy, extremely happy. Okay, so there are 5 levels, 5 names, 5 categories, 5 labels, but they have some internal ordering from low to high, Okay, in that case, you probably don't want to save this variable as a character. You should save this variable as a factor in our language. Yeah. I think in your first lecture or second lecture, they will talk about levels of measurement system. You have remember the 4 levels? The most commonly used system is called nominal, ordinal, interval, ratio. Yeah. So I can think of factors probably like the ordinal scale. So on that scale, you have different values, but those values are just categories, but they have like an internal ranking or ordering from low to high, from small to large, something. Yeah. Numerical is probably like the nominal scale in the measurement system. Yeah. And the interval ratio, that depends on if the 0 has if the 0 means nothing on the scale or not. If 0 means nothing, that means it's a ratio scale. If 0 is not real 0, it means something. That is interval scale. For example, the temperature of centigrade or Fahrenheit. 0 doesn't mean there's no temperature, right? If the degree is 0 centigrade, it doesn't mean there's no temperature. There is temperature, right? It's freezing cold. Yeah, Kelvin, that's a ratio. Yeah. At Kelvin scale, 0 degree means no temperature. There's no molecule movements. Yeah, that's a ratio scale. But it's kind of controversial. Some different people may have different opinions. So, all right. So on the ratio scale, you can't calculate the ratio. You can only calculate difference, right? Like today is 4 degrees hotter than yesterday. You can't say today is so suppose today is 20 degrees centigrade. Yeah, yesterday is 10 degrees centigrade for whatever reason. So today is 10 degrees hotter than yesterday. That's a valid comment. But you can't say today is twice hotter than yesterday. It doesn't make sense. I know 20 divided by 10 is 2, but that ratio doesn't make sense because the scale doesn't allow you to make that operation. Because there's something below 0, right? Yeah. All right, that's something different from distant from today's topic. So integer, numerical, character, and factor, they are the 4 types. Of course, there are other types of variables R can recognize. Okay, for example, logical. We'll talk about next slide. So let's put some time spend some time to work out the factor variable, the ordinal scale. Now, how to change the type of variable? You can use this code. So suppose height is the integer, and then you want to you want to change the type of variable from numerical to integer, you can do this. Okay, so currently mass is double means means numerical. You can save the decimals. So suppose I want to change the mass into the type of an integer. You can do this. Data set name, dollar symbol, variable name, and then the assignment operator, and then as integer. Again, it type the variable name. Sorry, data set name, dollar symbol, variable name. I can copy this. Go to R. So if I write this one, data set, that's how we find a variable in the data set. You write a data set name, data frame name, and then dollar symbol, and then variable name. So I'm going to redefine this variable mass in the data set SW as an integer variable, because originally it's a double, it's a numerical variable. It's a numerical variable. It's numerical variable. So if I run this line, highlight it, and run, or I put a cursor at the end and then command enter, and then I check the class. So class function is used to check the variable type. If you don't want to run the structure or glimpse or the whole data set, you can use class to check a single variable. Now the type is integer. Okay, that's how we can change the types of the variables. Sometimes we need to, but probably not. So you can see, because I didn't change the names, the original column is overwritten. So before it's numerical, now it's integer. If I want to keep the original column of mass and then create a new column, but save the new column as an integer, I just need to rename it. Okay. Oh, it's done already. So I need to do something else. I can call this one. Let's change the height. So I call this one height. Height dot int. Okay, so let me show you. So if I give a different name, if I run this line, my original height will not be changed. It's still there. It's still numerical. And I'm going to create a new column in the end. The new column will copy the values from the original height column, but it will be saved as an integer. Okay, let's try this. Control Enter. And then let me open my data set, SW, and go to the back. Now I have a new column here, HIT underscore INT. Why? Because I specified it here. Okay, so if you don't want to overwrite your original column by changing the type, you can create a new column just by different name here. Otherwise, if you use the same name, the original column will be overwritten. Okay, yeah. And I can check the class of the new column. It should be integer. Okay. All right. Just some small trick. It may be useful sometimes. Yeah. All right. Let's spend some time about factor now, and then we can finish. Factor is like ordinal scale. Okay. So so let's create a new column called the hair color factor. So currently hair color is this class SW. Let's check what's hair color. Type. Currently it's a character. Currently it's a character, and then current is character. And then I want to have a look at all the values in this variable. You can run this one, unique. Okay, unique. SW haircut. So run this line. You will see all the unique values in the variable in the column of hair underscore color. Okay, it's a bit messy. Here in the console. Currently in my data set, in the column of a hair color, here, this column, there are so many different values. Blonde, missing value NA, none, brown, common gray, black, blah, 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 and a blonde DE, okay, unknown. So it's a messy data set, right? So suppose I'm going to create a factor variable for hair color, and I put it on the ordinal scale, and I want to give the values of hair color on the scale from light to dark. Okay, so first of all, let's convert the hair color into a vector type. Okay, so how do we do that? So we go to SW hair underscore color. I'm going to name it differently. I will name it like a vector. Okay. It comes from as vector SW comes from here. You see that? I'm going to create a new column called the hair underscore color called underscore vector. It's a copy of the hair color in the SW data frame, but save the new variable as a vector, so s dot vector. As written in my slides here. Okay. In my slides, I actually overwrite the original column, but I don't want to do it now. I want to create a new column. Okay. And then Control Enter. And I can double check the hair color. Vector, the new variable should be recognized as a vector variable. Vector, right? The original one is character. And if I go to my data set, I should see a new variable at the bottom. At the end, that's the new column vector. Now, it's not finished yet. Why? Because to create a vector variable at ordinal scale, you have to tell R the ranking of the levels, the ranking of the categories on this ordinal scale. Okay, the ranking of the categories values in this vector variable in your data frame. If you don't specify it, I will rank them alphabetically. Okay, so how to check the levels? We just use levels function. Okay, see. So for a vector variable, for ordinal variable, we can check the levels by using the levels function. So SW hair color vector. See what you get. That's the currently recognized levels of the hair color vector variable. It's ranked automatically by alphabetic order. Okay. It doesn't make sense because I want to rank the color in terms of the darkness of the color. Okay, maybe the first one is white, and then gray, and then brown. No, white, brown, brown, gray, whatever. I mean black, whatever. Okay. So currently it's ranking alphabetically. The levels of hair colors in the columns are ranked alphabetically. It doesn't make sense for me because I want to rank them by the darkness. So how do I do that? You need to do like this line. Okay, that's probably the hardest part for today, and then it's done. The hardest coding part for today. So we can specify the levels of a vector variable in R. To specify the levels of the ordinal vector variable in R using this line of code. Okay, you may want to remember this because you may need to use it in your assignment, or maybe you don't. I don't know. Yeah. You can always come back to this slide, this page, and this line to figure out how to do it. Okay. So let me copy out. I'm cheating, sorry. Control C. Just one reminder. Sometimes when you copy the codes from other people or PDF something, be careful with the double quotes, okay? Because sometimes when we copy double quotes from Word document or PDF, the format is changed. So we may need to re-enter double quotes again. Like here, the double quotes is not the double quotes we use in RStudio. So we just need to replace all the double quotes here. I don't know why. Maybe I have some other languages installed in my computer. I guess that's probably the reason. So once I replace all the double quotes, just re-enter them again. The error message, the scary red cross disappear. Question? Yeah, I will email you the copy, the link to download the copy in PDF. So here I'm going to, so I should tap this one, vector. So we saw it before. Now the levels of the hair color vector is messy, is alphabetically ordered. That doesn't make sense to me. So how specify the order of the levels of this vector variable? I just have to write this, just rewrite it. Data set name, the vector variable name for me is a hair color vector. And then we define as a vector, and then we put the levels here. That's how you specify the levels. So here is this part. You write the vector variable name you want to create, the name of the vector you want to create, and then here that's the where the value comes from. Okay, because I have the variable already in the data set, I just use itself. I just use the variable itself. But if I didn't have this variable hair color vector in my data set already, this part should be the hair color, the original column. Okay. And then the important part is here. You specify the levels here. You write levels equal, and then you use the C function, C and the brackets, that will create a vector of values. So in this vector, you specify the names of the values from left to right. The left one is the lowest one. So for me, it's white, and then blonde, and then brown and black. Those values names comes from this column. Actually, come from here, right? Again, the names has to be precise and then case sensitive. Yeah. If the original white is a capital H, a capital W, then you should write capital W here. Otherwise, it won't be recognized. It will be error. We can change the values of a column later. We will learn that next week. How to recode the values in the column. Okay, we'll learn that next week. Yeah, but currently we just use it. We just learn how to specify the levels. So the levels values has to be 100% accurate. Case sensitive as well. Now you can see I'm lazy. I only specified 5 hair colors. So from left to right, from low to high is a white, blonde, gray, brown, black. How about the other values? So if I didn't specify the level of the other values in the original column, they will become missing values in my factor variable. So if I didn't, let's try this line of code, okay? Highlight it and run. And then I check my levels again. I check it again. Now it's correct. From low to high is white, blonde, with E, and gray, brown, and black. And then the other values will become missing values. See? The other values will become missing values. So if I use unique, I should only see 5 values now. So just be careful when you specify the levels of a factor. Make sure you do what you want. The values have to be the names have to be precise. Yeah. And the good thing of have a factor variable is that once we have a summary of a factor variable, we will have these frequencies of each level. I have a 4 white, 1 blonde, 1 gray, 18 brown, 13 black, and then 50 missing values. Because I didn't specify the other hair color values levels. Yeah, they all became missing values. Yeah. But if I have a, let's try this one with the original hair color variable. I don't think it will run. Let's try. The original hair color is in a character type. So if it doesn't run on character type. It doesn't calculate the frequencies of each level. It only works for factor variable. Yeah. All right. I forgot this one. Okay. All right. The last tab is I want to talk about is a logical variable. So logical variable has only 2 values, either true or false. So for logical variable, it's only either true or false. The value is only either true or false. And then we can create a logical variable by doing this. So first of all, we can check Let's have a look at the SW and height. That's the 87 heights of the 87 people, characters in the data set. We can ask if every one of them, if they are higher than 170 centimeter, okay? Just by running this line. If you run this line, you get a bunch of logical answers. True, false, true, false, true, false. Okay. Some are true, some are false. Skywalker is higher than 170, but C3P2, C3PO is shorter than 167, 170. Now you can save these logical answers into a new variable. Okay, in my slide. Time to finish. We can save it into a new variable. We call this one maybe called tall, okay? Or whatever you like it. So we can create a new variable. Let's call it tall. It comes from this bunch of. It comes from this logical evaluation. If I run this, I will have a new variable called tall in the end, and then its values are just true, false, true, false, true, false, true, false. Okay, that's how we can create a logical variable. And then if you check the class of the logical variable, it should be logic. Data set name, variable name is logical. Okay. So we learn numerical, integer, character, vector, which is a bit complicated, and then logical. These are the 5 commonly used types of data. We also have other types like date and time. In R, we probably won't use it this semester, I think. Yeah. So, all right, and then the last page is the I just put here. You will get a link on my to download a copy of the slides. That's just commonly used arithmetic and the logical operators in R. Just kind of, if you can remember them, you are a genius. Just keep the slides for reference in case you need to use them, like how to calculate a log x space. Okay, so log, let's say, what's the log of base 5? What's the log of 25 with base 5? It should be 2, right? Because 5 to the power of 2 is 25, okay? And then what's the log of 100? Why is 4 point something? Because if you don't specify the base, if you use natural E, the natural base as a base. You know the E? It's a, is it called Euler's constant or something? I remember. Yeah, Euler's constant. Yeah. And how to write exponential is this either head or double multiplication. So 3 to the power of 3 for that 27, is it? Yeah. Or you can write like 3 multiply 3. Oh, did it mean? Ah, am I wrong? Yes. I don't know what happened here. I think R is very stable. Yeah, it should be. Yeah. So this commonly used math operators and logical operators. Yeah. So less than, larger than, less or equal to, and this is not, this is an and this is all. Okay. Yeah. Okay. That's all for today. If you haven't logged attendance, please do it, and I will email you all the registrants to this workshop this afternoon. That email will include the links to this attendance form and the feedback form. They will only take you less than 1 minute. And then also a link to the copy of the slides, and also a final link to the recording. Okay. We went over a little bit 10 minutes because I promised to finish up by 11:30. Any questions for people online and also people in the room? All good? I can stop recording.